All right, we're going to review box and whisker plots. The main things you need to know are the parts of a box and whisker plot, because your SOL question isn't going to ask you what's the median or what's your lower quartile. It's going to expect you to know what these mean and be able to read a word problem or critically think to get your answer. So your lower extreme is your smallest set of data, smallest number in the set of data. In this case, it's 60. So even though my number line goes to 50, my point is right here saying the smallest number of data is 60. This is also called your minimum. Okay? My lower quartile is called my Q1, and that's just the number in between your minimum and your median. We got our median right here in the middle. The median is always in the middle of the box. Okay, and we can see that looks like it's about at 82. Our upper quartile is also called Q3, and that's the middle number between the median and the upper extreme. So we can see that's at about a 90. The last one is our upper extreme, and you'll often see that as called the maximum. All right, there's a few more things that you need to know about box and whisker plots, and one of those is your range. If you want to know the range of something, you just simply take the biggest number and you subtract it by the smallest number. So for book 1, my range would be between 40 and 5. So my range would actually be 35. Let's look at the range for book 2. Okay, my range for book 2 would be between 35 and 10. So that gives me a range of 25. And that's how you find your range. You're taking these, your minimum minus your maximum. Okay. Now let's look at something called inner quartile range, and I'm just going to label it IQR. Inner quartile range. The prefix inter means in between. So this is saying between quartiles and the range of that. So you just find the range by looking at Q3 minus your Q1. So Q3, or my upper quartile, is 35. And my lower quartile, Q1, is 20. So 35 minus 20 is 15. All right. So if we were looking at the inner quartile range for book 2, I see that the inner quartile ranges between 30 and 15. So it's 30 minus 15, and that's 15. So they actually have the same quartile. Another thing that you need to know, and I'm going to erase all of this, okay, that box and whisker plots are split into 3 sections. So here's one section, here's another section, a third section, and a fourth section. And each section, believe it or not, even though they are different lengths, they all represent 25%. Okay, so this is 25%, this is 25%, this is 25%, and this is 25%. Okay, so it's just like 4 quarters and a dollar. You have 4 sections of the box and whisker plot, each one representing a quarter or 25%. So what do you think the percentages is between 10 and 15? Hopefully you said 25 because it's just one section. What would be the percentage from here to here? So what's the percentage from my minimum all the way to my Q3? And hopefully you said, well, here's one section, so that's 25%. Here's another section that's 50%. And a third section, that's 75%, because each section is 25% of the data. Okay. Now let's go and look at what our SOL problems look like. This says, which statement is best supported by these data? A says the range of the data for intersection 2 is twice the range of the data for intersection 1. So if we're looking at intersection 1, to find my range, I know it's my maximum minus my minimum. So my range for intersection 1 would be 550 minus 350, and that'll give me 200. All right. My range for intersection 2 would be, I'll do it like this, 650 minus 250, and that'll give me 400. So let's go back. It says the range for data for intersection 2 is twice the range for intersection 1. And we can see that that's true. 400 is twice as big as 200. So I know that A would be my answer. But let's just look at B and make sure. B says the lower quartile for intersection 1 is greater than the lower quartile for intersection 2. So, whoops. Let's look. So my lower quartile for intersection 1 is about 375. And my lower quartile for intersection 2 is 400. So the quartile for intersection 1 is not greater than intersection 2, so I know that's not right. All right, C says the interquartile range for intersection 1 is the same, and that's when we subtract our Q3. Oh, geez, I'm sorry, guys. To find interquartile, remember that's when we subtract our Q3 from our Q1. All right, let's go on to the next one just for time. Okay. This one says, Katie recorded the number of miles she drove for each of 9 days. She drove a different number of miles each day. The box and whisker plot summarizes information. All right, this statement right here is great and all, but it's not giving us really any important information. So let's keep reading. It says Katie drove 30 miles on each of 2 additional days. So that means 2 numbers are going to go into this data, and they're each going to be 30. She redrew the box and whisker plot to include this data. Which statement must be true? Now, if I just add in another 30 in here, is that going to change my range? No, because my smallest number is still 10 and my greatest number is still 80. B, the value of the mean remained the same. When you find the mean, you have to add up all of the numbers that are in this set of data and then divide it to get the average. And we don't know all of the individual numbers within this set of data. We only know 1, 2, 3, 4, 5 numbers. So whenever box and whisker plot asks you about the mean, go ahead and cross that out. You cannot find the mean from a box and whisker plot. C says the value of the median remained the same. Now I can see that my median is 30. If I added 2 additional 30 miles in there, my median is still going to be 30. Okay, so C would be my answer. All right, if we look at D, it says the value of the interquartile range increased. And, we didn't add any different numbers. We just added 30, and 30 stayed the same. So it didn't mess with our interquartile range. So D would not be the answer. All right. So let's look at this one. You're going to see things that ask you to analyze the box and whisker plots. So let's look and see which one would have the greatest median. Okay. And hopefully you would say, well, here's my median, which is right about 45. Maybe I drew that line crooked, 45, 46. Okay. They could ask you questions like, which one has the greatest interquartile range? Go ahead and find that out. They could ask you which one has the smallest range. Go ahead and find that out. Remember, to find range, it's your maximum number minus your minimum number. Okay, and that's these guys right here. Sometimes you might have to estimate, and that's okay. If you're a number or two off, you'll be able to find your number for multiple choice. However, if you're like more than 5 numbers away from the answer choices, you've done something wrong. To find our interquartile range, remember that's Q3 minus Q1. And that's these guys right here, Q3 and Q1, Q3, Q1, Q1, Q3. The last thing I want you to remember is that each of these sections, there's 1, 2, 3, 4 sections. There's always going to be 4 sections. Just like there's 4 quarters in a dollar, there's 4 parts of a box and whisker plot, each part being a quarter and it being 50%. Okay, and that's it.